The Bermuda Triangle is not a single fixed location, but a loosely defined region of the North Atlantic Ocean, roughly between Florida, Bermuda, and Puerto Rico. What makes this area dangerous is not mystery, but a rare combination of geography, physics, oceanography, and human limitations. Let's break down the real science. First, navigation physics. The Earth has two different norths: true north, which points to the geographic North Pole, and magnetic north, which compasses follow. In most parts of the world, sailors must adjust for this difference, called magnetic declination. The Bermuda Triangle is one of the very few places on Earth where true north and magnetic north nearly align. Older navigation systems were not designed for this condition. As a result, sailors believed they were steering correctly, while slowly drifting off course over long distances. A small error of just 1 or 2 degrees, maintained for hours or days, can move a ship hundreds of miles away from its intended path, often into deep ocean, reefs, or severe weather zones. Second, ocean dynamics and rogue waves. The Bermuda Triangle sits near the Gulf Stream, one of the fastest and strongest ocean currents on Earth. This current moves warm water at speeds exceeding 4 to 5 knots, much faster than most ships can counteract if engines fail or steering is compromised. When strong currents collide with storms or opposing winds, they can generate rogue waves. Rogue waves are not tsunamis. They are sudden, extremely steep waves formed when multiple wave systems synchronize. Modern satellite data confirms rogue waves can exceed 30 meters, or over 100 feet in height. These waves strike with enough force to break steel hulls, capsize large ships, and destroy aircraft flying low during storms. Because rogue waves collapse back into the ocean immediately, they often leave little or no debris field. Third, atmospheric science and weather instability. The Bermuda Triangle is a hot spot for rapidly forming storms. Warm tropical air from the Caribbean collides with cooler air masses from the north, creating sudden thunderstorms, waterspouts, and microbursts. A microburst is a powerful downward blast of air that can force an aircraft straight into the ocean. These events happen so quickly that pilots may not have time to send distress signals. Before modern weather radar, ships and planes often entered these systems without warning. Fourth, methane hydrate theory, often misunderstood. Beneath parts of the Atlantic seafloor are methane hydrates, ice-like structures that trap methane gas under pressure. If destabilized by geological movement, large volumes of gas can rapidly rise to the surface. When methane bubbles enter seawater, the water's density drops sharply. Ships rely on water density for buoyancy. If density falls suddenly, a vessel can lose lift and sink almost vertically. Laboratory experiments and simulations confirm that this phenomenon is physically possible. However, it is considered rare and localized, not a constant threat but a contributing risk. Fifth, human psychology and reporting bias. Many Bermuda Triangle incidents occurred during heavy traffic periods in the 19th and early 20th centuries, when trade routes were dense and navigation technology was limited. Disasters in this region were heavily publicized, while similar accidents elsewhere were ignored. This created a perception of abnormal danger. When modern GPS, satellite tracking, sonar mapping, and aviation radar were introduced, the number of unexplained incidents dropped sharply. Not because the ocean became safer, but because humans finally learned how to navigate it correctly. In conclusion, the Bermuda Triangle is not supernatural. It is a convergent zone of magnetic navigation challenges, powerful ocean currents, extreme weather systems, rare geological conditions, and historical human error. Nature doesn't need mystery to be dangerous. If this explanation helped you understand the real science behind one of the world's most famous mysteries, like the video, share it with someone who still believes the MIT HS, and subscribe for more deep dive science explanations that reveal how our planet truly works.